What's going on, guys? In this video we are going to take a look at sequential system. Now here you can see from the state diagram there are 4 states A, B, C, D, and here A is 0 0, A is 0 0, and B is 0 1, 0 1, and then C is 1 0, D is 1 1. We are going to design the state diagram using flip-flops. Now here, since we have one input, if you have one number, it means there's just one input. So if it's just one input, we put the input as X. External input is X, no output. Now here we are going to decide how many flip-flops we are going to need. In order to find out how many we need to use, we have to look at number of states, because 2 power number of flip-flops should be greater than or equal to number of states. Now here you can see we have 4 states, so we have to have 2 power 2. So that's number of states is 4. So we need 2 flip-flops in order to do this design. Now if it was like 5 states, then we had to have 2 power 3, then we need 8 flip-flops, but we will not use some of these things because we will just leave some of them empty and use 3 flip-flops. But in this case it's exactly matching 2 flip-flops, so we are going to use 2 flip-flops, and we can decide what flip-flop we can use. Let's use D flip-flop for Q1. We are going to use D flip-flop. And for Q2 we are going to use T flip-flop. Okay, that's it. For Q1 we use D flip-flop, for Q2 we use T flip-flop. Now D flip-flop and T flip-flop, let's look at the truth table for D flip-flop and T flip-flop. For T flip-flop, Q and next state. Now let's look at the relationship. When T is 0 and Q is 0, if it's same, it remains the same, and if it's different, it toggles. That's the T flip-flops characteristics. Let's write it right here. T and Q next state. If the T is 0, it remains the same, and if T is 1, it toggles. So if it's 0, it just be 0. If T is 0, it just be 0. But if T is 0 and Q is 1, then it toggles, it becomes 1. And if T is 1 and Q is 0, it will just be 1. And if T is 1 and Q is 1, this one remains 0. Now here we have to know the backward relationship. Like we know that if T is this, Q is this one, Q next state is this. But when we design the circuit, when we design this structure, this design, we have to know Q and Q next state, what Q and Q next state gives us the T, because we are going to choose the T truth table based on the Q and Q next we are getting. Now in order to do that, we have to look at the pattern here. So I put it backward, like instead of arranging like this, Q next state, and I put the T right here. And if Q is 0 and Q next state is also 0, then T is 0. And if Q is 1, and if you can see, if both of them are same thing, it remains 0. If both of them are same, it remains 0. That's easy way to remember. If both of them are same, T is 0. If both of them are different, then T is 1. Okay, that's the T flip-flop truth table. We had to know this one in order to solve this circuit. Okay, now let's look at the D flip-flop. For D flip-flop, D, Q, next state. If this one is 0 and this is 0, this one remains 0. If this is 0 and 1, this one is 0. And this is 1 and this is 0, this one is 1, and this one is 1 and this is 1, this one will be 1. And if you want to know the direct relationship between D and Q next state, that is this Q next state. When the D is 0, Q next state is always 0. And when the D is 1, Q next state is always 1. Now, like this, like we created here, we had to know the opposite way, because we are only going to look at Q and Q naught to decide what value that D is going to get. So we had to know the opposite relationship. So let's put Q next state and D. Now here you can see when okay, let's look at the pattern right here. Here it depends on the Q next state. If the Q next state is 0, D is always 0. And if the Q next state is 1, D is always 1, as we created before. So it doesn't matter what Q value we have. If the Q next state is this, that's going to be the same thing we are going to have for D. So here 0, 0, 0, 1, 0, Q next state is 0, so it's going to be 0. 0, 1, Q next state is 1, so it's going to be 1. And 1, 1, Q next state is 1, so it's going to be just 1. Okay. Now this is our relationship we make. Now the next thing is we are going to create the table. Let's get rid of this one. Okay, let's get rid of this one for now, because I'm going to create the table. Here we are going to have the table for current state, input, next state, and then the flip-flops. Okay, here we are going to have the current state. Current state is Q1, Q2, and then input is X. And then next state is Q1 asterisk and also Q2 asterisk. And the flip-flop we are going to use is D flip-flop and a T flip-flop. Okay, now let's look at the current state. Here we have 4 states. So we have 0, 0, 0, 1, 1, 0, 1, 1. Let's start with 0, 0. At 0, 0, when the input is 0, what we are going to get? If it's 0, 0, it's A. When the A get 0, input 0, it goes to 0, 1. 0, 1 right here. Then let's look at 0, 0, the input is 1. 0, 0, input is 1. It's going to go to the next state, that is 1, 1, 1. And B, if it's 0, 1, and the input is 0, it's going to go to 0, 0, 0, 0. And if it's 0, 1 and the input is 1, it's going to go 1, 0. And after that, C, if it's 1, 0 and the input is 0, it's going to go to 0, 0. And if it's 1, 0 and the input is 1, it's gonna go to 0 1, and if it's 1 1 and the input is 0, it's gonna go to 1 0, and if it's 1 1 and the input is 1, it's gonna go to 1 1 again. Okay, now here we have all these states. I should have wrote it. Let's do it on top. Let's copy the same thing on top. I'm gonna just copy and paste it right here, because we cannot see the down things. Okay, select, let's see if I can copy this. Oh, I can. Copy and paste it right here. I should erase some of the stuff first. Let me erase these things. Okay, let's erase some of these things. Okay, we are going to need these two tables, this one and this one. Okay, we are going to need these two tables in order to solve this one. Okay, I'm going to paste the table right here. Paste it over here. And let me write it clearly. Okay, this is 1 1 and this one also 1 1. Now, if you look at the relationship, if it first we are going to look for D flip-flop, and we decided previously for Q1 we are going to use D flip-flop, and for Q2 we are going to use T flip-flop. So in order to find out what are the things we are going to have for Q1, we had to look at, let me highlight this one with a color. Okay, let's use green. We are going to use Q1. We are going to look at Q1 and Q next state to decide the truth table for D1. Okay, that's why we need to know this relationship we created here. So this is what you are looking at, D flip-flop. When Q and Q next state are 0, and you can see it depends on the Q next state alone. D flip-flop, if Q next state is 0, it's going to be 0. If it's 0, 0, 1, 1, 1, 1. So we can just copy the Q next state for D1, because it's just Q next state is going to be exactly same as D flip-flop. So 0, 1, 0, 1, 0, 0, 1, 1. Okay, that's Q next state. Now for T flip-flop, we've made a relationship right here. For T flip-flop, if if both of them are same, Q and Q next are same, it's 0. If both of them are different, it's 1. So let's look at that one. Let's use a different color for that. Q2. Okay, if both of them are same, it's gonna be 0. If both of them are different, it's gonna be 1. Okay, here 0 0 same 0. Here see 0 1 different, so it's gonna be 1 different 1, and 0 1 is different 1, 1 0 is different 1, 1 0 is different 1, 0 0 is same, so 0 0. We are in the 6th one here. 1 2 3 4 5 6. 6th one 0 1 different, so it's gonna be for different it's more different T flip-flop. For different is 1 1, then 1 0 different 1, then 1 1 same 0. Okay, that's the truth table for D flip-flop and T flip-flop. Now after we create the truth table, we are going to use the K-map to simplify and find the equation. Now let's get rid of all these things. We want to create the K-map for D1, T flip-flop and D flip-flop. Let's start with D flip-flop. K-map. Okay, 0 0 0 1 1 1 1 0, and this one is 0 1 and Q1 Q2, and X is the input. Okay, now first we are going to do it for the D flip-flop. D flip-flop, you can see 0 1 0 1 0 0 1 1 0 1 0 1 0 0 1 1. Okay, now K-map. K-map, we can do it by 2, like it goes like 2 4 8. Here the simple case is 2. Here we have 2, and also here we have 2. Okay, for this one, what remains the same? X is the only thing remains. X remains the same, so X, and Q1 remains the same, 0 0. So Q1, but it's 0, so we have to put a bar. Then for this one, Q1 Q2 remains the same, X changes, so Q1 Q2 is the only thing that's gonna remain right here. Q1 Q2, that's the K-map for D flip-flop. Now let's look at the K-map for the T flip-flop. Okay, Q1 Q2, then this is 0 0 0 1 1 1 1 0. This is 0 1. Now for T flip-flop, T flip-flop is 1 1 1 1 0 1 1 0 1 1 1 1 0 1 1 0. Okay, now here the symbol, here we have the most highest possible number is 4, and then after that we can create 2 for this one and 2 for this one as well. Okay, now let's write the truth table for this one. T1. In the fourth, let's look at the fourth 4 1 together. What is not changing? Q1 is not changing, but it's 0, so we have to put a bar for that. Then let's look at these two things. For this one, Q2 is not changing, but it's 1 already, so we don't have to put a bar. And also X is not changing, but X is 0 at state, so we have to put a bar. Then here, if you look at this one, for this one, Q2 is not changing, but it's 0, so we have to put a bar. And X is not changing, but it's 1, so we can keep it as it is. Now based on the truth table, we can design our flip-flop. Let's go ahead and put 2 flip-flops. Okay. Okay, D1, and this is Q1 bar, Q2 bar, and this is T2. Okay, now let's look at the first one. D1 X Q bar, Q1 Q2. Now X is, we can put the X right here. This line is X. Okay. Then X and Q1 bar. So we can put an AND gate. Multiplying is AND. X and Q1 bar. So Q1 bar is right here. I connect that one also with this here. And also Q1 Q2. Q1 comes from here. That's also Q1 and Q2 also connected to AND gate. Q2 connected to an AND gate. And both of them are connected to OR gate and goes to the D1. Both of them are connected to an OR gate and goes to D1. Okay, this is for the T flip-flop. Now let's look at the T flip-flop. For T flip-flop, there's a Q1 bar. Q1 bar, that's alone. And it should be, all of them are connected to OR gate. This one plus this one plus this one. So I put the OR gate right here. Let's use a different color to verify. To differentiate. OR gate. Now, okay. Now the next thing is Q1 bar. Q1 bar right here. Then Q2 X bar. Q2 connected right here. And X. Okay, let's take this one. Q2 and X bar. Q2 and X bar. So we have to connect this one and X bar to an AND gate and then connect. So let's take it through this. I put this one to, so this is not going through this one. Okay. And here we let's connect the AND gate right here. Okay, AND gate. Doesn't work like this. AND gate, I had to put it behind. Okay, AND gate Q2. This is X bar actually, so I had to put a NOT gate right here. NOT. Let's use a different color. NOT gate connected to AND, and then we have Q2 connected here, Q2 also connected to this AND gate, and both of them goes to this OR gate. Then after that, Q2 bar and X connected together. Okay, so all of them are connected to this OR gate, and that gives us T. Let's call this one T1, and that's our flip-flop. D1, T1. Actually, I put the name T2. Let's keep it as T2. T2, D1, T2. This is T2 right here. Okay, that's how we do that. I hope you guys find this video helpful. Thanks for watching. And if you're trying to learn Digital Logic Design 2 or Computer Architecture, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. Oh, let me see whether I missed something. Oh, these two are AND. I made a mistake here. Q2 bar and X. That is AND. I cannot just put the wire together. I have to put an AND gate. AND gate connected here and connected here. And that's it. I hope you guys find this video helpful. Thanks for watching. And if you're trying to learn DLD2 or Computer Architecture, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.